As a first example of how useful inner products can be, consider the following question. What is the length of a vector? It's a geometrical question. So you have a vector u with its components u1 and u2. Those components are with respect to an orthogonal basis. So for example, ex and ey, they make 90 degrees and both measure 1. So you have these components, u1 and u2, with respect to this basis. And if you have that, the length squared, denoted like this or like that, is just the components, the summation of the components squared. u1 squared plus u2 squared. It's easy. It's a simple calculation. That gives us the length squared. Well, if you just want the length here, denoted like this or like that, you just take the square root of the calculation above. Square root of this summation. Let's see an example. If I have a vector with components 1 and 2, so these components are with respect to this vector, ex and ey. If you start with that, the length squared, denoted like this, is the inner product between both, here or here, but that is just multiply the entries. So 1 times 1, 1 squared, 2 times 2 is 2 squared, it's sum, like this. That gives us a 5. So 5 is the length squared. Well, the length of the vector, we just take the square root of this thing. So the only thing that is important is that you always remember that in order to compute these lengths, you need to have components with respect to an orthogonal basis.